integral 0 to infinity e to the power of negative ax sine bx dx. Alright, if you cannot read this properly, just listen when I read it. Integral 0 to infinity e to the power of negative ax sine bx dx. What's the method for integrating this? Well, the same, integration by parts, isn't it? Alright, you can choose this as your u and that as your dv. Alright, let's do that. First of all, write this as a limit. Integral 0 to infinity e to the power of negative ax sine bx will be limit c approaches infinity. It doesn't matter what you call, whether it is b, a or c. I'm choosing c here because there is a b already here. I don't want to duplicate that. So this can be written as limit c approaches infinity, integral 0 to c. So our infinity has been replaced by c and we let c approach infinity at the end. Integral 0 to c e to the power of negative ax sine bx dx. Alright, we use the table method. Can't we use the table method there? Or can we? Now the table method will not work there. Why not? Because the table method will work only if the quantity you choose as u will, when differentiated continuously, will reach 0. In this case, what happens? When you find the derivative of e to the power of negative ax, it will keep on revolving. Negative e to the power of negative a e to the power of negative x, a squared e to the power of negative x, negative a cube e to the power of negative x. It will probably roll over and over. Similarly, integrating sine bx dx will give you negative cos bx over b, negative sine bx over b squared. It will roll over. So you cannot use the table method here. So what we're going to do is we will use integration by parts repeatedly. We will use integration by parts twice. Alright, let's now choose our u and the dv. Our u is e to the power of negative ax. Therefore, what is our du? Du is negative a e to the power of negative ax dx. Our dv is sine bx dx, and therefore what is v equal to? V will be negative cos bx divided by b. If you cannot see this on the screen, take a note of those. Our dv is sine bx dx, and integrating that will give you v equal to negative cos bx over b. Alright, let's now write this integral. What will that be? We will have integral u dv is u times v minus integral v du. Now we're going to leave the limits out for the time being. We will go back and pick the limits once we finish with these steps. So we'll say integral 0 to c e to the negative ax sine bx can then be written as u times v. Look at that, u times v. This is negative e to the negative x times cos bx divided by b, u times v, minus integral 0 to c. Now remember, I said we will leave the limits. Now this is part of the integration. That means that limit actually applies to all this. So we're going to leave this for the time being. We will come back to that later. Minus integral 0 to c of v du. V is negative cos bx over b, and du is negative a e to the power of negative ax dx. And you can see there's a negative, that will make it positive, and that negative will remain as it is. So once again, it will be negative e to the power of negative ax cos bx over b minus. Now, there's an a on the numerator, if you notice, and a b on the denominator. We can factor that out. A over b comes out. Integral 0 to c, what is left in here is e to the power of negative ax times cos bx dx. That is what is left there. And you notice this is now an expression similar to the one that we started with. And so what we're going to do is we're going to take this and do integration by parts one more time. Alright, watch this carefully. This is an important type of problem. Okay, let's repeat integration by parts for this, where e to the power of negative ax is your u and cos bx dx is your dv. Alright, u equal to e to the power of negative ax. What's our du? du is negative a e to the power of negative ax dx. Our dv is cos bx dx. Therefore, integrating will give you v equal to sine bx over b. And therefore, what will this integral be? Well, it will be u times v e to the negative ax sine bx divided by b minus integral v du. Alright, let's write that. So, integral u dv is uv minus integral v du. And we will use this to work out this part. Everything else remains the same. So this will be negative e to the power of negative ax cos bx over b, that's that term, minus a over b times, we are now writing the terms for this integral, where we chose this equal to u, and that's our dv. So what is that integral equal to? A over b times u times v. U times v, the product of these two terms is this, minus integral 0 to c v du. So that will be sine bx over b, that is v, du is negative a e to the power of negative ax dx. Alright, let's do one more simplification then. Again, if you notice, an a over b can be brought out in here. Is that right? So it will be, that term will remain the same, no change there, minus a over b times, we're going to leave this the same. The change we have there is a over b has come out. There's something else that came out. If you notice, that negative sign becomes positive. How? We brought out that negative sign and that made this positive. That will be a over b came out. What is left there is e to the power of negative ax sine bx dx. Alright, now if you notice here, this is the original integral that we started with. So by doing integration by parts, we came back to the same integral we started with. So does that mean there is no end to this? Well, actually there is a beautiful way we can resolve this dilemma. Alright, let's see how it can be done. Now if you notice, this is the integral that we started with. Integral 0 to c sine, integral 0 to c e to the power of negative ax sine bx dx. This is the integral that we wanted to evaluate in the beginning. And that's what gave all these after doing integration by parts twice. And if you look, this term, integral 0 to c, e to the negative ax sine bx dx is exactly that one. We produce the same integral. Alright, so this is the left hand side, and the right hand side is this whole thing. And let's simplify that right hand side by doing what? We can actually distribute this a over b into here. And I want you to watch this once again. This is the left hand side we started with, and all these things that we have been doing is the right hand side. So the first term on the right hand side is this: negative e to the power of negative ax cos bx divided by b minus, let's distribute that, minus a over b. That gives you a e to the power of negative ax sine bx divided by b squared. Now minus, because that's minus, and multiply this a over b with this a over b, gives you a squared over b squared integral 0 to c e to the power of negative ax sine bx dx. Alright, now you can see I colored the left hand side and part of the right hand side red. Why did I do that? Well, because they are both the same. And so all we need to do is try and combine them. So all we need to do is move this term, this whole term containing this, to the left hand side and combine them together. Let's do that. So what I did is, this is the left hand side there, and I moved negative a squared over b squared integral 0 to c e to the negative ax sine bx dx to the left hand side. It became positive a squared over b squared, same integral. And now what's the right hand side? The right hand side will be now these two terms. So integral 0 to c e to the negative ax sine bx dx plus a squared over b squared integral 0 to c e to the negative ax sine bx dx, that is this term moved to the left, equal to these two terms, negative e to the power of negative ax cos bx over b minus a e to the power of negative ax sine bx over b squared. Alright, let's now go to the next page and try and simplify this. And now can you tell me, how will you simplify the left hand side? Think about it. You can see on the left hand side, this integral 0 to c e to the power of negative ax sine bx dx is common. We can pull it out. And what will be left? There will be a 1 left here, plus an a squared plus b squared left here. You see how beautifully you can put it together into a single term there. Let's do that in the next page. So this is what we had, and we are going to now combine, in other words, factor out the integration part. There you go. So that will be integral 0 to c e to the power of negative ax sine bx dx is factored out. What is left in here will be a 1, plus what is left in here will be a squared over b squared. And that's equal to the right hand side. Can we simplify the right hand side? Yes, we can take b squared as the common denominator. When it does that, the numerator here will multiply by b. So you will get negative e to the power of negative ax b cos bx minus e to the power of negative ax a sine bx all over b squared. That became a single term. And what are we looking for? We are looking for this integral, isn't it? That is the quantity that we want to evaluate. And therefore, in order to find the value of this, all we need to do is divide both sides by this quantity, 1 plus a squared over b squared. So we have First of all, let's simplify this one more time.